today, and I just met him this morning, though I've seen him diligently studying out here in the study area at least the last year.
Yes.
So, anyhow, he is representative of the Academic Support Center and would like to talk to you a bit about that.
Okay. Good morning, everyone. As said, I'm Jeff Burrell. I'm one of the peer tutors in the Academic Support Center. I tutor math through Calc 3 and physics. I'm glad to see other people are in the morning tide going for chemistry. Personally, I prefer calculus, but chemistry is good too. The Academic Support Center has peer tutors and professional tutors available. We have several peer tutors for chemistry, as well as math and science. We also have a professional tutor for chemistry, and I've noticed over the last few days that people have been coming in and utilizing that resource, so that's very good. The ASC is located in room 160. It's just across the hallway from the bookstore downstairs. It's a free service for all ARCC students. We only tutor those classes that are taught at ARCC, though. And so we welcome you to come down if you need some help with chemistry or other classes. We welcome you to come down if you just want to talk a little bit more about chemistry with the professional tutor or with some of the other tutors down there. We also have computers that don't have any specialized software. I don't know if you use that in the chemistry courses, but if you use any of the lab software, you'll have to go down to the computer lab. However, we have all the Microsoft Word applications, or Microsoft applications, so if you need to write a report or something, that's available for you. The ACC is open from 8 a.m. to 8 p.m. Monday through Thursday, and 8 a.m. to 4 p.m. on Fridays. So look forward to having anyone that wants to come down, come on down. And I'll leave some bookmarks up here that give the hours and some information about the tutoring at the ASC. So thank you very much.
Yep, thank you. It's my bad for not having somebody come down here earlier this semester. I would say that the biggest mistake that students make in this course is when they start struggling is that they wait until the last minute, and then it's too difficult to get caught up and everything. So, but we do have an exam coming up Friday, and if I'm not available for my, or you're not available during my office hours or whatever, or I'm not around, our Academic Support Center does offer those free services to you. Okay, so there were a couple questions, and I did get the wording wrong because I am writing these questions up for the first time in Socrata this semester, and I write them up the same morning that we go, and sometimes I make a mistake like I do here today. And so let's just very quickly review the two that were on here. First one was LiH2PO4. This one was, help me out here, folks, dihydrogen phosphate. Right. Now, Mark had asked the question about why don't we have a 2 after the lithium? Well, how about if we had written it like this? What would we have called it if it was this formula? Right, lithium monohydrogen phosphate.
That wasn't entirely my question.
Oh.
I was just curious why, because lithium is a positive 1 charge and hydrogen is a positive 1 charge, why do they not both have 2? Because phosphate is a 3 negative charge.
Yeah, but that's not the phosphate ion. It is the dihydrogen phosphate ion. It is a polyatomic ion.
I see.
Yep. And so these are 2 different polyatomic ions. I guess I misunderstood.
Thank you.
The question. Yep. Anybody else? Okay, and then what was the second one that was on there? Anyone? Remember? No? Okay, well then I guess I'll need to show answers. Oh, A. Well, that's very helpful. Nobody remembers it? What was the second?
Tetraphosphate.
Oh, tetraphosphorus. So it was, let's see, was it to give the formula or to write the name? Probably give the formula. So the name was tetraphosphorus dicoxide. And so the formula for this would be P4O, what? 10. Any questions on those two? We do have a test scheduled for Friday, and I do have somewhere here a sign-up sheet. We did pass this around the last class, so I'm not going to pass this around again. But if at the end of the class you want to make a special seating request, you can please put your name onto the sheet here and your special request. Anybody that has the special accommodations, you should have already contacted me about those accommodations. The exam on Friday will be worth 100 points. It will take, I suppose, on the average, about 30 minutes. I try to write it, so on the average probably about 35 minutes. So I try to write the exam so the person who finishes the exam first finishes in about half of the total time that's available to all of you. Now, what I can do is this. If you want an early start, it has to be unanimously decided in here that we have an early start. And I'm willing to give you an early start. But if one person, like if you work overnights or something, night shift, and you can't make it in here, I cannot give the entire class the opportunity to start earlier if it excludes even one person. So, I don't know that I would like to put you on the spot. So how can I do this? Well, let's just try it. Would anybody opposed to an early start on Friday? Anybody opposed? And by early start, I would say 10 till. 10 till. Anybody opposed to an early start? Okay. Now, if you're too shy to raise your hand now, I'll give you a chance to come up after class here to let me know that, hey, I work the graveyard shift and I just can't get in here. And I will put the announcement out on D2L as soon as class is over. And if you don't see it, remind me, because I am getting old and forgetful. And so just remind me, and if it works for all of us here and it's unanimous, I will let us start 10 minutes early. We do, however, need to stop at the very latest in here at 8:55 because we have another class coming in, and I think they might be testing on Friday here as well. So they're going to want to get in here and take their exam on Friday. So what will happen then is if you're not finished at that point, I will take your test and it will be completed. So you'll have about 65 minutes then to work, assuming that it does work for everybody in here. It is written, however, to be for a 50-minute period, where I usually allow them to run 5 minutes over. So I'd say about 55 minutes. Average should be about 35 minutes, and I always try to write the exams so that the person who finishes first and does reasonably well would take about half the entire time for the exam. So that's my goal when I write the exam. Any questions? Okay, as far as expectations, we are covering chapters 1 and 2 and part of 3. And whatever those sections are, they're already specified on the syllabus. I don't have to tell you exactly what it is. We should have been through enough classes by now that we know that whatever's on the syllabus is what you expect on the exam. What I can tell you is that about 30% of the test is going to be problem-solving type things. We have to do calculations and show your work. And those will be like worth 10 to 15 points each. There will be about 30% of it that will come from nomenclature, and those will be like fill in the blank, where you either write the formula or give the name. And the other approximately 40% will be multiple choice questions, which will include other major concepts from the course. So like how many significant figures, how many neutrons and stuff like that. Yes, sir?
Will we be getting like practice problems to work on?
Yes, you have those in your syllabus. So if you are doing those practice problems that are in your syllabus, and there are ones that are also signed as the extra credit practice problems, those are what you'll be doing. And once we're wrapped up today, we should have about 20 minutes left, and I have a set of practice problems, kind of quick review that we'll be doing in there. But I never provide study guides in here because your study guide is your syllabus. It does tell you everything that you should be required to do, as well as those practice problems in there. What I'd give you for a study guide would be absolutely no different from that. Those practice problems already assigned. Okay. All right, well, let's wrap this thing up here. Acids is where we're going to finish off today. And these here are molecular compounds. In which hydrogen is written at the front of the formula. And we're going to start with binary acids. And of course, if we talk about binary acids, the word binary means two. So these are going to be compounds that have two elements. One of those elements is going to be hydrogen, and that hydrogen will be written at the front of the formula. So the convention we use for naming binary acids is this. We have a hydro prefix and we have an IC acid suffix. And in the center we have the root name of the other element. So again, hydro, root name of the other element, and then an IC acid suffix. And they take on this name when dissolved in water. If they're not dissolved in water, they retain its name as if it were a molecular compound. So for example, let's say that we had HCl aqueous and we had HCl gas. Well, which one of these two is going to get assigned the acid name?
Aqueous.
The aqueous one, right. So the name of this first one is going to be hydrochloric acid. Hydrochloric acid. But if it was present as a gas, we would call it, we'd name it just like we would name a binary molecular compound. Usually, again, we leave the prefix mono off if there's only one of it, so we'd call this one hydrogen chloride. So again, as a pure substance, we call it hydrogen chloride, but when it's dissolved in water, we call it hydrochloric acid. If we would go in the reverse direction, we saw something like hydroiodic acid. We wanted to write its formula. Then what we do is we locate where they are on the periodic table. And I'm going to get my periodic table out very quickly. If you don't have yours out, get it out. We see that hydrogen is located here. Iodine is located right here. Hydrogen, of course, is going to have a charge of 1 plus. The iodide, or the iodine, is going to be a 1 negative. So here we have a single positive and a single negative. What will happen to those charges? They're going to cancel out. Formula becomes HI. Now, to make it technically correct, what else do we need to add? Aqueous. Now, I will accept with or without the aqueous. Master in Chemistry, I believe, will accept with or without the aqueous. In fact, when chemists use it, we don't always put that aqueous in there. We look at the context in which it's used. If we're talking about it as an acid, we already know that it's dissolved in water. If we're talking about using in a lab, we would assume that it's already been dissolved in water because HI would actually come as a gas. So usually in the context in which we use it, we'd already know the phase, and so the phase label is not necessarily needed to be included. Likewise, if we simply saw HI, or simply as HCl, and we're using it in the context of an acid, you would know to give it its acid name. If we're talking about a railroad car had dumped over and had given off a gas, you would assume that you were then inhaling hydrogen chloride and not hydrochloric acid. So again, the context in which it's used will generally tell you some information as to the name we assign to it. Now, just to be sure there's no confusion here how we arrive at these formulas, let's say we looked at something like hydrosulfuric acid. In this one here now, if we want to assign the formula, hydrogen, of course, would always be H with a charge of 1 plus. The sulfur, however, would be S with a charge of 2 minus. So then when we go to write the formula, we'd write its formula as H2S. To be technically correct, we'd give a phase label of AQ. But again, with or without, as long as we know the context, simply writing H2S would be fine. But to be technically correct, if we're in total absence of any context, we'd put the phase label to indicate for sure that we know that it is given this name or formula only when dissolved in water. Any questions on these? Okay, then we are going to wrap up with oxyacids. In oxyacids here, these will always use their acid name. In other words, they have their acid name whether or not they are dissolved in water. So it's only the binary acids that we make the distinction. With oxyacids, we always give them their acid name whether they're dissolved in water or not. So to give an example of this, let's take these two. Let's take HNO3 and let's take HNO2. Now to assign names for these, I like to use what's called the four-square method. And so I'll kind of write something out like this. And to name them, what we'll do is this. First of all, we will identify and name the anion present in the acid. So identify and name the anion present in the acid. Then, what we do after this is we drop ATE from the acid name, well, not from the acid name, but from the anion name, and we replace with the suffix of IC acid. Now, of course, not all of the oxygen-containing anions end with ATE. Some oxygen-containing ions end with a suffix of what else? ITE, ite. In this case, what we do is we drop ITE from the anion name, and then we replace it with the suffix of OUS acid. So again, if it ends with ATE, you replace ATE with IC acid. If it's ITE, you replace it with OUS acid. There's a couple ways to keep these straight if you're looking for handy mnemonics. A couple of handy mnemonics is, here's one, I ate something icky. That's one way to think of it. The other way is to remember that ate comes before ITE, just like IC comes before OUS alphabetically. So you can think of them alphabetically, or you can think of them as I ate something icky, and of course the other one will go in the other direction. So then to name these over here using this four-square method, when we talk about identifying and naming the anion present, first of all, we'd write the formula of that anion. The formula of this anion that's present is going to be NO3 with a charge of 1 negative. The name of this anion is the nitrate ion. And so if this is the nitrate ion, the name of this acid is nitric acid. I remember supervising a high school teacher once calling it nitric acid and nitrate. It's not nitrate, it's nitric and nitrate. All right. Then this one here, the anion present would have a formula of NO2 with a charge of 1 negative. This is called the nitrite ion. If we identify it as a nitrite ion, the name of this acid is nitrous acid. Nitrous acid. If we try going the other direction, let's try something like this. Let's do oxalic acid. Again, I like to do oxyacids using this 4-square method, including the other direction. You would identify this as being an oxyacid because it does not have a prefix of hydro. If it has a hydro prefix, that would tell us it's a binary acid. Yes, sir?
Can we do anything with like hypoenite or?
Yes.
Okay.
In fact, we ignore those prefixes. The only prefix we can't ignore is the hydro prefix, because if we see the hydro prefix tells us that this is which type of acid.
Hypo. Like,
I know what you said. Yep. So we ignore those prefixes, but if we see a hydro prefix, that tells us a binary acid. If we see hypo or per, that has nothing to do with it being binary. Those are still part of the oxyacids. So we can basically ignore those and we still follow the same rules that we have. But the only prefix we can't ignore is the hydro prefix, because if we see the hydro prefix, that tells us it is a binary acid. Okay, so we come back on this one here. We have oxalic acid. And we'll do one just like yours, and since you just asked about it next. If we're looking at oxalic acid, this must mean it was derived from which anion?
Oxalate.
Oxalate ion. Good, with an ATE suffix. Then this would mean that you had to memorize that the oxalate ion was CO4 with a charge of 2 minus. To make it an acid, we would then combine it with which element? Hydrogen. And that charge on the hydrogen is 1 plus. So that means we need to combine these two together. If we combine these two together, we get H2C2O4. And so this here then, formula for the acid. So then going with one that you mentioned, does it work with hypo? Yes. Let's say that we looked at this one here. We want to get the formula for hypochlorous acid. So now if we want to get the formula for hypochlorous acid, we say that this has an OUS acid suffix, which means that this would have been derived from which anion? Hypochlorite. And so if this was derived from the hypochlorite ion, we then need to know the formula for the hypochlorite ion. Of course, that's not on your list of ions to memorize. What was on your list of ions to memorize was this one here, which is the chlorate ion. And then if we have a formula of ClO2 with a single negative, this would have been the chlorite ion, which means that ClO with a single negative charge is the hypochlorite ion. So this is ClO with a single negative charge. So we derive that from the chlorate ion that you memorized. Then to write the formula of the acid, we're going to combine it with which element? Hydrogen. And the charge on the hydrogen is 1 plus. Therefore, the formula for hypochlorous acid is HClO. HClO is the formula for the acid. Now, about the only monkey wrench in this whole thing is this. It turns out that there are two elements. There are two elements that have different root names in anions and acids. Anybody know which two elements those are? They are sulfur and phosphorus. They are sulfur and phosphorus. And the root name in anions, and if we look in acids, in anions, the root name of sulfur is, help me out here, it's sulf. And in phosphorus it is what else do we need here? pH. So in anions it's sulf and phos. In acids we add one more syllable. So in acids it is sulfur. In phosphorus it is phosphor. In fact, I already used this today without even telling you. I used it back here when we looked at hydrosulfuric acid. We didn't call it hydrosulfic acid, we called it hydrosulfuric acid. So again, they're different. So if we want to look at an example of something like this, let's say we want to come up with a name for H2SO4. We want a name for this one. We follow through our four-square scheme. So what we're going to do first is identify and name the anion present. The anion present, of course, would have a formula of SO4 with a charge of 2-. This here is called the sulf 8 ion. So we drop off the ATE suffix and we replace it with IC acid. But then we change the root name from sulf to sulfur, and then we add on the IC acid suffix. So again, in addition, then we added on the UR, we call it sulfuric acid. And sulfuric acid is, if you got here today in some sort of vehicle, sulfuric acid is the acid found where? Car batteries, yes, car batteries is the sulfuric acid. And where do we find hydrochloric acid in this room? Stomach, right. We got a whole bunch of it here. Everybody's got, your gastric juices are hydrochloric acid. Okay, any questions on nomenclature? Any questions? All right, here's what I'd like for you to do, and I will let you get started as soon as I see groups of 3 or 4. Get together in groups of 3 or 4. I don't care how you do it. If you're by yourself, we won't start. So get a group of 3 or 4 decided. Okay, and in your groups, here's what we're going to do. Exam 1 review. And it's on the Socrative app. You'll have open navigation. There are 5 questions on here. I think we got everything. We'll go ahead and get started. Once you get your 5 questions completed, you are free to go here today. So put in your answers. There's actually 3 questions that I consider to be pretty easy, 2 kind of medium, and 1 more difficult. And come exam time. Come exam time. The way I designed them, about 25% easy, 25% hard, about 50% medium. So that's how I designed. 25% easy, 25% hard, 50% medium.